The Link Trainer. Crude pilot training aids had been designed even before World War I, but the Link Trainer was the first flight simulator that had any significant value. History. In the late 20s, Edwin A. Link learned to fly while working for his father in Binghamton, New York, who manufactured organs and pianos. Because of the economic depression at that time, flying lessons became too costly. Link got the idea to shorten the expensive flying lessons by learning rudimentary piloting skills using a ground aviation trainer. Drawing from his expertise in air-driven pianos and pipe organs, Link used organ parts and compressed air to build the first flight simulator. In 1928, Edwin Link left his father's organ building business to begin work on a pilot trainer. In 1931 he received a patent on his pilot maker training device. Initially rejected by the flying community, most of his first sales were to amusement parks. In the beginning there was very little interest by the flying community in Link's trainer. Initially the trainer was meant for instruction of visual flight, but in 1934, after a series of tragic accidents while flying the Air Mail, the Army Air Corps bought 6 Link trainers to assist in training pilots to fly at night and in bad weather, relying on instruments. The second customer for the Link trainer was the Japanese Imperial Navy in 1935. Many Japanese pilots were trained in these Link trainers and used their skill and knowledge in fighting the American planes in World War II. World War II. The need for pilots with instrument training in World War II resulted, by the end of the war, in Link delivering 6,271 Link trainers to the Army and 1,045 to the Navy. The Link trainers were also used by 35 foreign countries. Although Army Air Force's aviation cadets flew various trainer aircraft, virtually all took blind flying instruction in the Link. How it works. The trainer used suction through fabric bellows to cause motion. Organ bellows and a motor provided the means for the trainer, mounted on a pedestal, to pitch, roll, dive and climb as the student flew it. Movement was controlled by valves connected to the control stick and rudder pedals. An instructor sat at the desk and transmitted radio messages which the student in the Link heard through his earphones. Inside the cockpit, the student relied on his instruments to fly the Link through various maneuvers while his navigational course was traced on a map on the desk by the 3-wheeled craft. Slipstream simulators gave the controls the feeling of air passing over control surfaces, and a rough air generator added additional realism during the flight. Restoring the Link trainer. In 1993, the Western Museum of Flight initiated the restoration of a 1942 Model C3 Link trainer. A crew of museum volunteers, using an accumulated inventory of donated obsolete and non-functioning parts of 1940s-era Link trainers, established the foundation for the restoration. This inventory consisted of 2 bases, 2 octagons, an almost fully equipped fuselage, 2 blind flying hoods, an almost complete set of Link trainer operation, overhaul, and maintenance technical manuals, and a sufficient amount of spare bellows, valves, turning motors, Telegon transmitters, and instruments. The restoration was a multi-phased program. For the first phase of the project, the crew tore down the existing components and meticulously drew up scale drawings that would be used to rebuild the trainer and its various mechanical, electrical, and pneumatic systems. All of the major valves, linkages, tubing, bellows, and instruments were diligently taken apart, cleaned, put together again and/or fabricated per the technical orders in the Link maintenance and overhaul manuals. The highly labor-intensive, time-consuming, and skilled work would require 2 years to accomplish. During this period, the process of putting together and completely rewiring the Link's base, central column, vacuum compressor, and main electric panel were accomplished. In addition, the Link's octagon with its master climb, dive, and banking bellows was completely restored. The restored octagon was mounted to the Link's base. Once completed, the base was fully restored with its now functioning vacuum compressor, wind drift motor, and main electric panel, Work now progressed rapidly onto the restoration of the Lynx fuselage, which was then mounted on the Lynx octagon, and the restored components were then carefully reinstalled. The next step was the restoration and installation of the Lynx instrument panel. The restored panel contained a fully functional magnetic compass, gyro horizon indicator, altitude meter, airspeed meter, turn and bank bubble, climb and dive indicator, engine RPM meter, clock, radio beacon, glide path indicator, fuel gauge, on/off switch, pitot tube heater switch, and fuel switch. Finally, the time-consuming recalibration and testing of all of the Lynx major and minor valves, electrical transmitters, mechanical linkages, vacuum chambers, and air dampers was completed. The Lynx was given its first full-powered systems test for instruction in the Lynx technical manuals. The final phase of the restoration program focused on the Lynx trainer's wooden frame, cloth-covered wings, with movable ailerons, and wooden tail with movable rudder and elevators. The wings frames were repaired as needed and their cloth coverings patched and sealed. The wooden tail assemblies were cleaned and sanded. The wings ailerons hinges, brackets, and cables, along with the tail's rudder and elevators hinges, cables, and brackets, were then restored to full working order. The assemblies were then painted in the 1940s style Army Air Corps trainer distinctive yellow enamel. The restored wings and tail were installed on the Lynx fuselage. The Lynx blind flying hood or canopy was completely restored. All the old, rotted cloth covering had to be stripped off and the wooden frame cleaned and strengthened. The last step in the process was the restoration of the Lynx instructor's desk, automated flight tracking device, radio, and the electrical and mechanical linkages from the desk to the Lynx base. Conclusion. The Lynx trainer holds a significant place in aviation history. It was the first true flight simulator providing safe training to hundreds of thousands of student pilots during the 1930s and 40s. No one knows how many lives, aircraft, and training dollars were saved during World War II as a result of the Lynx trainer. The restored Model C3 Lynx trainer is presently on display at the Western Museum of Flight at the Torrance Airport in California.